my dear students, and welcome to our Mathematics 10 session with me, your teacher, Mr. Pineda. In this lesson, you will learn about finding the nth term of arithmetic sequence. And without further ado, let us start with our lesson. Finding the nth term of arithmetic sequence. So here in our lesson about finding the nth term of arithmetic sequence, we will be using the formula for the a sub n, which is equal to a sub 1 plus the quantity of n minus 1 times the common difference c. So I have a video about deriving such formula about the nth term of arithmetic sequence. If you would like to visit the video first before moving on to the lesson, please do so. So in this formula, the common difference t is given by the a sub n minus the a sub n minus 1. And the main idea for solving any particular term in the arithmetic sequence using the formula for the nth term is by using the substitution property. I also have a video on how to manipulate equations, particularly the properties of equality. You may also try to visit the video first before moving on to this lesson. And now, for our example, so here in this problem, we need to find the 18th term of an arithmetic sequence with a first term of negative 6 and a common difference of positive 3. So in solving this problem, we may first try to write all the important details in the problem, for which here we would like to have the value of the 18th term. So we are writing a sub 18. Since that this is the question for this specific problem, then let us leave it blank for the meantime. And other information like the first term, which happens to be the a sub 1, which is equal to negative 6, and the common difference, which is usually written as d, which happens to be equal to 3. So, like what I have said, we will only be using the substitution property to replace all these corresponding variables with their respective values in our formula. Doing so, we have our a sub n, the a sub 18, and our a sub 1, which has the value of negative 6. And here we have the quantity of n. So this n corresponds to this subscript. Since we will be using a sub 18 for our a sub n, your n changes to 18. So your n will be equal to 18 minus 1. And at this point, the common difference d is equal to 3. So let us have the 3 here. Then we have to manipulate this equation. So by simplifying, we have this the a sub 18. So here we have to subtract 18 minus 1, which happens to be equal to 17. And this 17 will be multiplied with 3, so it gives us 51. Okay? And now we have a sub 18, d equal to negative 6, while this is equal to 51. Having these two numbers together gives us the value of a sub 18, which happens to be equal to 45. So this will be our answer for number 1. And let us proceed to our next example. So here we need to find the 125th term of an arithmetic sequence with a first term of 51 and a common difference of negative 7. Just like in our previous example, we have to write all the important information in the problem. Doing so, we have the question a sub 125 with a first term equal to 51 and the common difference which is equal to negative 7. So we have to substitute all these known values for a sub 1 and the common difference in our formula. So we let our a sub n be a sub 125, while the value of the a sub 1 is equal to 51. And since we let our a sub n be a sub 125, your n changes to 125. So writing this, and now for our common difference, this is equal to negative 7. And let us try to manipulate the equation now. So we have our a sub 125 be equal to 51. So having 125 minus 1, which is equal to 124. And now multiplying 124 with negative 7. So we may do some scratch work here. So this is 28, while this is 14 plus 2, 16. And this one is 7 plus 1, 868. So since we are multiplying positive with a negative number, the answer is negative 868. And let us write some other details in this equation. So we have this. And now we are only left with addition. So we add these two numbers together. So we may also perform scratch work here. So since we are adding two unlike sign integers, we are performing subtraction instead. So this gives us this number, which will be negative. So the answer here will be negative 817. So this will be our 125th term of this sequence. And let us proceed with another example. So here we have this problem. A finite arithmetic sequence has 24 terms. Write the arithmetic sequence if it has 17 and negative 3 for its initial term and common difference respectively. So here, instead of just knowing one particular term in this problem, we have to write the arithmetic sequence instead. So having this information. So the finite arithmetic sequence has 24 terms. Okay? So, and we have our initial term, which is also known as the first term. So writing a sub 1, which happens to be 17. So here is our 17, and this refers to our initial term, while the negative 3 refers to the common difference. So writing the value of the common difference, which happens to be equal to negative 3, then we may solve any nth term of this formula because we are given with a sub 1 and the common difference t, just like in our previous example. So doing so, we may have our a sub n be a sub 24 in this case. And substituting all this known information in our formula, we will obtain the equation a sub 24 equals the value of a sub 1, which is 17, while the n changes to 24, and our common difference d has the value of negative 3. And now let us manipulate the equation. So here we have our 24 minus 1, which is equal to 23. And we multiply this 23 with negative 3. And manipulating this further, we have 17 plus the 23 times 3. So this gives us negative 69. And let us simplify this expression. So adding these two numbers together gives us 52. Negative 52 instead. So negative 52. So that means the 24th term of the arithmetic sequence is negative 52. And since our goal is to write the finite arithmetic sequence with all of this information, then we may start with our first term, a sub 1, which happens to be 17, since that the common difference is negative 3 based on what you have learned about the definition of arithmetic sequence. We may continuously add this negative 3 to the preceding number so that we get the next succeeding numbers. Doing so, we have our 17 plus negative 3, which is positive 14. Adding another negative 3 gives us positive 11. And since we need to just write the finite arithmetic sequence, then we may try to cut this short by writing an ellipsis. So that means the sequence continues with the pattern observed with these first 3 terms, and since we have 24 terms for this arithmetic sequence, knowing that the 24th term is equal to negative 52, then we may just write the negative 52 at the end of this finite arithmetic sequence like this. And this will be our finite arithmetic sequence having 24 terms.